The standard, I got this off the textbook, so I think this is right. Observe and explain how parts can be related to other parts in a system, such as the role of simple machines and complex machines. And demonstrate the effect of simple machines on work, and it lists simple machines. Work is a transfer of energy. The formula is force times distance. So obviously if force or distance or both goes up, the work will go up. The greater the force, the greater distance something will travel. Therefore you know more work has been done. A simple machine is a mechanical device that changes the direction or magnitude of a force. Simple machines make work easier by allowing greater output energy using less input energy. That's just restating with how work, the formula for work and the, what's it called? Relationship, thank you. The 6 simple machines are lever, inclined plane, wedge, screw, pulley, and wheel and axle. A lever is a simple machine that uses a bar that pivots at a fixed point called a fulcrum. My example was scissors. They're levers because the handle is really a bar that pivots at a fixed point. That's how you make them open and close. These are the functions of levers. The 3 classes of levers. I really don't want to read through this. But,
give a brief description.
Basically, the first class, they
Does
can...
he have a laser pointer on your presenter? You can point.
First class levers can, they change the direction of force, and they can, depending where the fulcrum is, they can increase force or distance, and that's what a first class lever looks like. Second class levers, the load is between the fulcrum and the input force. Yeah, that's right. They do not change the direction of the input force. They help you apply less force, but you have to exert it over greater distance. And the third class levers, the input force of third class levers is between the fulcrum and the load. They do not change the direction of the input force or increase the input force. The output force is less than the input force, and this confused me. Because I was like, well, why would you want a machine that makes you do more work? And I figured out it'd be, I have the muscle here because, I mean, you're going to want to make it harder. It's like push-ups. I mean, if you want to get off the ground that bad, use your knees. You don't have to push yourself up.
Right.
So basically, yeah. Inclined planes. An inclined plane is a simple machine that is a straight slanted surface. They reduce the amount of force needed to move objects vertically, making hauling, loading, and moving objects easier because the same work is done over a longer distance. Ramps are inclined planes. A pulley is a simple machine that has a grooved wheel that holds a rope or cable. A load is attached to one end of the rope and an input force is applied to the other end. You can see my elevator and my Gangnam Style elevator.
That's awesome.
There's 3 types of pulleys. There's fixed pulleys, movable pulleys, and block and tackle. Fixed pulleys are attached to things that don't move. The input force and output force is the same. Movable pulleys are attached to the object being moved. They do not change the force's direction, but they increase force. These are both simple, and when you combine a fixed pulley and a movable pulley, you go to block and tackle. The mechanical advantage of a block and tackle depends on the number of ropes you use. Wheel and axle, a simple machine consisting of 2 circular objects of different sizes. Mechanical advantage can be found by dividing the radius of the wheel by the radius of the axle. A little VW buck sign, wherever it is. Turning the wheel results in a mechanical advantage greater than 1 because the radius of the wheel is greater than the radius of the axle. Doorknobs, hoses, and steering wheels are all wheels and axles. A wedge, a pair of inclined planes that move. The output force is greater than the input force, but the input force is applied over a greater distance. The longer and thinner our wedges, the better it will work, which is why you sharpen knives and axes, because they're thinner and therefore cut food and
it's easier to kill.
trees and people better. The mechanical advantage of a wedge can be found by dividing the length of the wedge by its various thickness. And a knife is a wedge, an axe is a wedge, but axe is not a wedge. Screws are inclined planes that are wrapped around in a spiral around the cylinder. When the screw is turned, a small force is applied over the long distance over the inclined plane of the screw. Meanwhile, the screw applies a large force through the short distance it is pushed, and obviously a screw is a screw. The conservation of energy cannot be created or destroyed, but it can change forms. And this applies to simple machines because they do not produce energy out of thin air when you use them. They use an input force and greater distance to create a greater output force. Hey Daniel. What you reading? What was that?
Your wonderful project.
What could possibly be more interesting than my project? I'm kidding. I'm messing with you. My compound machine with pliers. We have a lever and a wedge, and because they've got a wedge, it's an inclined plane because they're two inclined planes. And I'm not sure if it was a wheel and axle or a screw that held it together, and I couldn't find our pair of pliers to look.
I think it's just a pin. That's the one Chris said that would be like a little axle.
Okay, that's what I thought. Okay, and as you can see, they go like pliers. My bibliography, that's a random thing from Google. I use the interactive textbook online for most, and then I use Google Images, and I got bored, and YouTube gave me lots of good tips. And that's the end.
I did YouTube for my last
Now you can read, Daniel.